In this video, we're going to write a piecewise defined rule for my graph. So number 17, write a piecewise function for the given graph. Pretty straightforward. I'm going to break this up into two pieces. So I'm going to look at this one first, and then we'll look at this one second. So what we want to do is we want to come up with a function for each one of these terms, or each one of these pieces. And to do that, we're going to need to kind of figure out what the equation of that line is. So looking at this one on the left here, we have negative 5, 5 as a point, and we have negative 3, 3. So I'm going to use those to try to find the slope of that line. So I'm going to use negative 5, 5 and negative 3, 3 to find my slope. So we want to do y2 minus y1, or x2 minus x1. And that's going to be 3 minus 5 over negative 3 minus negative 5. Now you might be able to count and all that, but we're going to do the algebraic way. So I get negative 2 over negative 3 plus 5 would be a positive 2. So that means my slope is negative 1, which makes sense, all right, because it does seem to be going down about 1. So that's pretty good. I'm looking at the equation y equals mx plus b. So I do need to find a b value. And to do that, unfortunately, I'm going to need to calculate this using more algebra rather than just looking at the graph. So y equals mx plus b. I know that m is negative 1. All right, so we already calculated that. I'm looking for b here, and my x's and y's, I can choose either of the points that I already had, the negative 5, 5, or the negative 3, 3. So I'm going to use the 5s. Really no reason that I'm picking that one over the other one, but my y value would be a positive 5, and the x value is going to be negative 5. So I can now solve this. I get 5 equals 5 plus b. I'm going to subtract 5 from each side, and b would be equal to 0. So that tells me that for this graph here, that line is going to be y is equal to negative 1x, and then I could say plus 0. I don't really need that. I'm going to write that in for now, just so we see what's going on here. But all of this calculation here, this is for that. So we're looking at y equals mx plus b. Now, I want to do the same thing for my second equation, or a second function part. So we're going to look at that there. And then we'll get into the limitations about like the greater than less thans after we've come up with the two equations. So I'm going to write this one in red. I have the point negative 3, negative 4. And I have the point 3, 2. All right, so same thing, I'm going to plug these into y2 minus y1, or x2 minus x1. I'm going to find my slope. So 2 minus negative 4 over 3 minus negative 3. 2 plus 4 would be 6. 3 plus 3 would be 6, so that's going to be a positive 1. Again, kind of looks like it makes sense. I should have a positive number because I do have a positive slope there. We do see where the y-intercept is, so we could calculate it the exact same way that we did the other one, but I'm going to kind of take a shortcut here. We know that, sorry about that. We know that this is negative 2 here, so this is going to be negative 1. So my b value is negative 1, my m is that 1. So my equation is going to be y equals 1x, or just x, minus 1. All right, and that one, this is the work here for our second part. So my f of x, I'm going to write my function, piecewise function now. F of x is going to be equal to, I have y equals negative 1x. Actually, we don't need the y, sorry about that. Let's get rid of those y's. So I have negative 1x and 1x minus 1. Let's just highlight these so we remember where they came from. And now what I do need to state is for when this is true. So we're going to say for what x values we're looking at. Well, this negative 1x starts at negative 3. So this here is at negative 3, and we're going left. So we want the numbers that are less than negative 3. So x is going to be less than negative 3. I'm only going to write the less than symbol because I have an open circle at that negative 3. Now the second equation, the 1x minus 1, that's going to be 4. Now I want the numbers that are greater than negative 3. So same thing, I'm starting at that same spot and working right. So x is going to be greater than negative 3, but this time I have a closed circle. So I'm going to put the equal bar underneath that greater than symbol. So to do this, whenever you're looking for the piecewise function, you're going to need to calculate or figure out the equations for each section, which the work is shown here, and we've done that. They're asking us to do the same thing in number 27, but this time they're looking for the domain and the range. So we need to come up with the equations, and then we can talk about what the domains and the range are. But let's do the equations first. So again, I'm going to highlight these portions. This time we've got 3 of them, but fortunately for us, one of them is a constant. It's going to be a straight line. That one will be pretty easy to figure out. So starting with this first one, we have this point here, negative 9 and positive 1. And what do we have here? We have negative 2, 8. So same idea. I need to find the slope of this line. I need to figure out what the intercepts would be. I can count them. Again, I'm going to write it out, but we'll have 8 minus 1 over negative 2 minus negative 9. So 8 minus 1 is going to give us 7. And then negative 2 plus 9 would be 7, which is going to be 1. And if I look at my graph, it does make sense because I'm going up 1 over 1, up 1 over 1 each time. So this is going to be my m value. So for equation y equals mx plus b, we're going to have y equals 1x, and then we need to figure out our b value. Since I know the slope is 1, I'm going to count up 1 over 1 here, up 1 over 1 again, and that's going to make it pretty clear that my y-intercept is 10. I could calculate that the same way I did up here in this highlighted yellow portion, but let's make our lives easier. This one we can just count it, so let's not kind of stress ourselves out with that. So that yellow portion, this was our work, and this is our equation. We'll get into the limitations or the range and the domain in a minute. This middle green one, what's going on here is that this is at 4, so it's just flat at 4. My equation is going to be y equals 4. That's it. There's nothing else we have to worry about that. All right, it's just going to be y is equal to 4. And then my final one, here I have 0, negative 6, and this is 5, 4. I know the y-intercept is there, so I just need to figure out the slope. So I'm going to do 4 minus negative 6 over 5 minus 0. So that'll be 5, 10 over 5, which is 2. And again, if I count the slope, I do see that I'm going up 2 over 1, up 2 over 1. So my m value would be 2. Again, y equals mx plus b. Y is equal to 2x. Our b value is a negative 6 for this problem, or this part of the problem. So this is our work, and that would be our equation. So my piecewise function, we have f of x would be equal to that first part, we have 1x plus 10, we have 4, and we have 2x minus 6. Now we need to state when this is true. So my first one, this 1x plus 10, starts, the lowest x value it is negative 9. There's a closed circle, so that tells me I'm going to have an equal symbol. And then it goes to negative 2. So my x is between it's negative 9 is less than or equal to x, and then that is less than negative 2. No equal sign there because it is an open circle. Right, so take note of that. The 4 value, where does that start? Well, that starts at negative 2, and it goes to where x is 0. So this is going to be negative 2 is less than or equal to x, which is less than or equal to 0. Equal symbols here underneath the inequalities because we have closed circles. And then my final one, 2x minus 6, it's going to start at 0, open circle, so it's going to be less than x, and it's going to go to 5, closed circle, because, closed circle means that I'm going to use the less than or equal to symbol. So that's given our function. So this is our piecewise function. We want to determine the domain and range. So domain is our x values. The lowest x value we have is negative 9. That's included. So it would be less than x. I'm going to write this as an inequality, and then we'll write it as interval notation. It goes up continuously. There's always a value. So I have a value at negative 9, negative 8, 7, 6, 5, 4, 3. There's a value at negative 2. There's a value at negative 1 and 0. And then it goes over to 5, which is included. So interval notation-wise, I would say negative 9 to 5. My range, my lowest number is negative 6, right, and that's going to be right here. And then my highest value is this positive 8. The negative 6 is an open circle, so we'll just have the symbol less than. And then the 8 is also an open circle, so again, less than. So when I'm writing it as interval notation, I'm going to say negative 6, 8. And then that would be my domain and range, so that answers the question. Be careful with your parentheses and brackets. And again, calculating these ones weren't too bad because, especially number 27, we were able to count to find the slope. But if you're not able to count it, you're going to use the slope formula. And then if you're not given the y-intercept, if it's not all that clear, you would have to use, again, what's highlighted in yellow here. Plug in your y, m, and x once you found the slope, and then solve for b. So hopefully that clears that up, and you should be good to go.